Roll number 10.
Sir, I think he has not joined it.
Yes, yes.
Roll number 10 is not joined.
No, sir.
What is his name?
Rajesh Kumar.
This should not be like this because already a resource person has entered on the screen and he is not joined. This is very ridiculous. Teachers should be take very care that before 3 o'clock, 10 minutes before you have to join on the platform. Respect and discipline is the most important for the teachers. Is there any technical problem? Is there? Who is the next? Then you can introduce if you have the, because I already shared the biodata of Professor Mudgal, sir.
Okay. Next, roll number 11.
Rajesh Sheikh, sir. I'm audible,
Yes,
Rajesh
sir.
Sheikh, sir. Sir, now you take
Yes, sir.
being a team leader, sir, you should take very important because ये पहली तैयारी करके रखो ना ये टीचर कौन
Yes,
लेता है
sir. I
पहले
already
join होना
prepared
चाहिए।
and
नहीं वैसा नहीं सर, आपको टीचर्स में से आपको
already
लेटर
sent them.
आपका पता में
हाँ, टीचर्स में से लीड कर रहे हैं लेकिन उतना टाइम ही नहीं मिलता ना बोलने को। आप लोग बोलते तो बीच में इंटरफेयर भी नहीं कर सकते ना।
ना उनको आपको बैला पड़ेगा because being and you appointed from this group as a leader there, so it is your duty that 10-15 minutes before make them very correct. You give the ring or call or miss call, tell them in time you should be joined. So please now you continue. Somebody
Yes, yeah.
introduction.
Morning session also I want to declare the name, but no time is given.
Okay, you just share it on the group. Someone will introduce.
अरे नाव कशाला उघडेल रिकामी कुठे कशाला करायला तू
आइए इसमें
sir, may I introduce Dr. Mudgal, sir?
Yes, 19. Roll number.
Sir, roll number 19, sir.
Yes. Okay, sir.
Okay, thank you, sir. Thank you very much. So on
हेलो
behalf
हेमंत
of
सर
Sir, wait करा sir आता. Please. Roll number 19.
yes, sir. Sir, on behalf of the refresher course, I would like to take this opportunity to introduce our next speaker, Dr. V Mudgal, sir. Sir is a retired professor and the former director of the Center of the Water Resources, Anna University, Chennai. Sir has a qualification BA in Civil Engineering in 1984 from the University of Mysore. Then sir has completed sir's ME from the Hydraulics Engineering in 1987 from University of Mysore. Sir is also a PhD from Hydraulics Engineering in 1994 from Indian Institute of Technology, Bombay, that is IIT Bombay. Sir is having a vast experience of lecturership in the college like SDM's College of Engineering, Dharwad. Sir is a senior research associate in Aerodynamics Laboratory, IIT Bombay. Sir also worked as an assistant professor from 1996 to 1998 in Sardar Patel College of Engineering, Mumbai. He's also an assistant professor in Jimma University, Ethiopia. Assistant professor also in Center of Water Resource, Anna University, Chennai. Sir is having a membership of 4 membership in our professional bodies, having 28 publication, 26 conferences, and 1 book chapter. PhD thesis that include 10 PhD students completed under sir's guidance, and 2 students are ongoing. There is also a thesis examiner for 10 PhD students, MA Master of Engineering thesis guidance for near about 70 students completed their masters under sir's supervision. There is a BU project guidance for where 7 students completed, and sir got the funding of near about 75 lakhs from the different agencies and the consultancies of about 21 lakhs. Sir is also a short-term trainer program for that sir has conducted near about 5 short-term training program and 20 trainings sir attended. Sir is also having a publication in the review of the journals that is 6 in number. So with this brief introduction, I would like to invite Dr. V Mudgal sir to please enlighten us with their words. Thank you, sir.
Yeah, thank you for the kind words. Am I audible to everybody? Yes, yes, you're audible.
Yes, sir. Yes, sir. Yes, sir. You are audible.
How are you?
Yes, sir, you are
How
audible,
are
sir.
you?
You are
Yeah,
audible.
my old friend Professor Murthy here. I think he was the previous speaker.
Yeah, yeah.
I'm sorry, had I known, I would have joined your lecture.
No
But okay, probably the next time I will join you.
problem. Sure, sure.
And let me take this opportunity here. First of all, to thank Professor Bandela for inviting me to give this lecture. You must have seen from my biodata that I'm not a qualified environmental engineer or an environmental scientist. But it so happened that after joining Anna University, I got into learning for myself about integrated water resource management and things like that, and that is how little bit I wouldn't say deviation from hydraulics and hydrology, but we would consider them to be a sort of required knowledge that is these days. Also, I have my senior friend here, Professor Mule, who was at this Institute for Remote Sensing at Dehradun. So there we became friends. And after that, he also used to call me for some lectures online, of course. And I think the same thing has been continued by Professor Bandela. And
Yes, sir. Yeah. Thank you for that.
with this brief background, so today I have thought of talking a little bit about everything, in the sense that we say that water is everybody's business. Yeah. So hydrologists are interested in water, environmentalists are interested in water, sociologists, advocates, name any stream, whether it is natural sciences group of people or social sciences group of people, or the bridge, which is economists. So everybody is interested in water, and that's what makes water very important, whatever stream of field that you take. And for today's talk, I would be talking a little bit about climate change, slightly different perspective, and also on this nexus between water, energy, and food. Okay. And let's also talk a little bit about sustainable development, and specifically, we will focus on the 3 sustainable development goals, which are related to water, energy, and food, and how they are linked. Okay, so this is what I would be looking at today. So what I will do is now I will close the video and then start with the presentations. Yeah. So let me share my screen. So is the screen visible to everybody?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. It is visible, sir.
Yeah. Thank you. I have also shared a PDF file with Professor Bandela. So I will request him to share with the participants. Okay. So as I told that today we will be talking about climate change and the interlinkage between water, energy, and food. Yeah. So this is the background. Then what is sustainable development? And what are the sustainable development goals of the United Nations? And any sustainable development goal, it has a goal. Then there are targets, And to measure whether those targets are met, you have the indicators for them. And the success of whether any sustainable development goal has been achieved or no is done through a process which is called as monitoring and evaluation. Okay. Of course, I will not go into this details about monitoring and evaluation because that itself would be another talk. And let's look at water, energy, food nexus and what are the challenges. I think I may skip the case study for, let's say, want of time also. So let's see this climate change. Okay. So now here, this is the photograph of the Earth, probably for the first time when astronauts went into the outer space sometime in 1960s. And then they took the photograph of this beautiful blue, white patch Earth. Then we realized that Earth is another celestial body which is rotating about its own axis and then orbiting around our sun. And you know that there are many, many, many suns in the galaxy and so on. And if you consider the dimensions, the Earth itself is a very small speck. And out of that, we humans are still very, very small. So that gives a sort of humbleness for us to think that we are insignificant in all respects. Okay, whether it is time or whether it is space, we are very, very insignificant. Maximum we may live for about 100 years, but 100 years compared to the billions of years through which this cosmos is there, that makes it very, very, so we all, our mind may say that we are great, but that may not be so. Now, life, as we know, when we say life, it is the so-called intelligent life. That is what we call ourselves, to be intelligent species. So this life is possible in a very thin film around the Earth. So if you think about the Earth, its radius is about 6,400 kilometers approximately. But then a thin layer of about 5 to 6 kilometers, which is made up of atmosphere, hydrosphere, and geosphere, sometimes also called as lithosphere. This is where we find life. Okay, so life is also, restricted to a very thin layer in this enormous cosmos. And this life is possible because all these three are interconnected in the biosphere. Okay. And we know that the position of the Earth in the solar system is quite unique in the sense that this is the only place where you find water in three phases. Yeah. In solid phase, in liquid phase, and in gaseous phase. Supposing you go near the sun, then this solid and liquid phase will vanish. It will be only in the gaseous phase. And if you go far away from the sun, then it would be only ice. Okay, only the solid phase. So both only in the gaseous phase or only in the solid phase, life is not possible. So that is what, again, makes Earth a very unique position in the solar system. So this we all know, but then it also requires from our side to introspect that what is it that we are dealing with. Of course, we are looking at environmental science, isn't it? So when we say environmental science, we are basically thinking about the life on Earth, right? Now, there is one interesting hypothesis, which is called as the Gaia hypothesis or the Mother Earth hypothesis, which is proposed by James Lovelock and Lynn Margulis sometime in early 70s, 1970s. Now, what this hypothesis says is that all organisms and their inorganic surroundings on Earth are closely integrated to form a single self-regulating complex system. So we will see what is this complex system. Yeah. So this word is important, system. So when you say what is a system, basically when you break it down, it is nothing but you give a system an input, then it will give an output based on what you call as the transfer function. Okay. So if you just try to write what is this thing, you can think of as a black box. You have the input and you have the output. And this transfer function could be the knowledge that we have, or it may not be the knowledge which we don't have. So in such cases, if we don't know the transfer function, we call it as a black box model. Okay. And these systems also can have what you call as a feedback. Okay. So sometimes the feedback would be negative and sometimes the feedback would be positive. So, and many such systems, when you join together, either in series or in parallel or in combination of both series and parallel, you will get what is called as a complex system. Okay. So now this complex system has properties more than the individual components of the system. Okay. So that is what we call as the emergent property of the system. So you remember that a complex system has properties which is more than the individual parts. So for example, you take any machine, let us say you take a bicycle. So a bicycle will have two wheels, a brake system, a seat, a pedal, a sprocket wheel to drive through the chain and so on. But if you disassemble, then you will get the subcomponents or the subsystems. Only when you combine them together, it will give you the property of transportation. Yeah. So if you break it down, transportation is not possible. So when you combine it together, that property for the cycle which gives you to move from one place to the other, that is the emergent property. Yeah. To give another example of emergent property, let's say that we human beings, we have, let us say, let's take the digestive system. Yeah. So there are so many things that go into the digestive system. You have the stomach, the small intestine, the large intestine, then you have the pancreas, liver, and so on and so forth. Yeah. So all these, if you break down, yeah, you will not get the property of giving metabolism and energy to the person. Yeah. but only when it is combined in a proper way, then you will get the emergent property of metabolism and, energy that is given to the person. Okay. So this is how complex systems are. So what are the complex systems? It has input, it has an output, it has a transfer function. It may or may not have a feedback loop. The feedback loop could be positive feedback loop or it could be negative feedback loop. Now, this simple systems can be combined together either in series or in parallel or in combination of both series and parallels to give what are called as emergent properties. Now, in this hypothesis, complex systems are self-regulating. So I will talk about this self-regulating in the sense that it will try to achieve equilibrium. Okay. So, for example, have a if you have no questions, I request you to kindly mute your speakers. Yeah. Okay. Yeah. Thank you. But if you have a question, you can stop me and ask. No issues. Yeah. So when we say self-regulating, it's just like you have a concave saucer-like thing, and if you have a small ball or a marble, and you push the marble, it will come back to its original position. Yeah. The property is called as self-regulating. So we have to imagine that this earth is a self-regulating complex system which is made up of living and non-living things. Okay. And it tries to maintain the conditions which will help for life to exist on the planet. Okay. So that is why we call it Mother Earth or Gaia hypothesis. Okay. So Gaia is another name for Mother Earth. Okay. So this is what is the thing. Okay. Now, the biosphere and the evolution of life forms contribute to the stability of global temperature. Yeah. Ocean salinity, oxygen in the atmosphere, and other factors of habitability in a preferred homeostasis. Okay. So I'll talk about this homeostasis in the next slide probably. So what happens is that in this Gaia hypothesis, it tries to stabilize the global temperature. Okay. So if the temperature is too high, then, that's what we are moving towards. That is global warming. Ocean salinity, if the salinity is too high, then again, life is not possible. Oxygen, I think, is about 21% in the atmosphere. If you have too much oxygen, then what will happen? Yeah, everything will get burnt. Okay. So that is why oxygen, nitrogen, carbon dioxide, all these have to be in a given percentage or in a given amount. Then only life is possible. So that factors of habitability are in a preferred homeostasis. Homeostasis is some sort of equilibrium. So there may be a disturbance, but then it will try to come back. It will try to self-regulate to come back to its original position or in a way that life is possible. So this ecological hypothesis has also inspired analogies and various interpretations in social sciences, politics, and religion under a vague philosophy and movement. So everybody is now talking about this Gaia hypothesis based on their background, based on their training, based on their knowledges. Okay. So let's look at this homeostasis. So you can compare this homeostasis with a seesaw. Okay. So when you have the seesaw, yeah, if there is a change, if there is an imbalance, then this change is detected by the receptor. Okay. And I think roll number 15. Any questions?
Hello. Hello. Please mute your mic. Roll number 15.
Yeah, thank you. Yeah, so now this change is detected by some receptor, and this change the input to some sector. And the output information is sent along different pathway to the effector, and then the effector will give a response to the feedback to influence the magnitude of stimulus and returns variable to homeostasis. The best example for this sort of homeostasis can be a baby which is trying to walk. Yeah, you would have seen how a baby learns to walk. Yeah, so it's so beautiful to see a baby trying to walk. What it does is that first it will lose its balance. Yeah, and then if you see, the baby tries to stretch its arms so that if it leans towards the right, then it will try to balance towards the left, and so on and so forth. So the toddler tries to balance itself. Okay, so it tries to come to a equilibrium. Or this you would have, seen in when you are trying to learn bicycle riding or so on. And our body tries to maintain a temperature around 37 degrees Celsius. If the temperature increases, then the nerve cells in the skin give signal, and the temperature is regulated to our brain, then we sweat. Yeah, so when we have fever or something like that, we sweat so that the body temperature is regulated. So this is another example of homeostasis. But we have to be careful here that the disturbance should not be too large. Yeah. Supposing if the body temperature is very high, then it will affect our brain, isn't it? That is why you will see that people put ice and cold bath over our forehead when we have high temperature. Okay, if the body is not able to maintain the temperature properly, then you try to do artificially try to bring the temperature down. Otherwise, it is going to be difficult for the person. Yeah, so this is another example. Now, this example is of, let us say, negative feedback. Yeah, so the temperature is increasing. You want to bring back the temperature down. So this is example of negative feedback. The other example which is given for positive feedback is that when you get a wound, yeah, the wound when you have you will get blood that is coming out through the wound, bleeding you want to stop. But in nature, what happens is that there will be more bleeding so that a clot is formed and the bleeding is arrested. So bleeding is an example for positive feedback. Sweating during fever is an example of negative feedback. So these are two examples that as a human being I have given. But then this type of homeostasis is achieved globally through different, what shall I say, different components. So there is a computer model, probably you can Google for it. And Lovelock himself has initiated that model. It is called as a Daisy World. Yeah. So you can Google for Gaia theory and Daisy World this thing. Then you will find a lot of applications. So one of the examples that is in the Daisy World is about daisies which are around the earth. Okay. Supposing if the temperature goes on increasing, you have two types of daisies, white daisies and black daisies, and how they interchange their position depending upon the amount of heat that is coming onto the earth. Yeah. So it's very interesting. So people who are interested, you can look for this Daisy World computer program. Now, a view of the earth that sees itself as self-regulating system made up from totality of organisms, the surface rocks, the oceans, and the atmosphere tightly coupled as an evolving system. So the theory sees this system as having a goal, the regulation of surface conditions, so as always to be favorable as far as possible for contemporary life. Now, the reason why I'm talking of this Gaia hypothesis is that till now, whatever education system or the thinking that we have is based on disciplinary approach. Yeah? Supposing I'm a civil engineer, for me all problems look like civil engineering problems. Somebody who is a economist, he will think only about the cost, the benefit, okay, how it is going to improve the profit and so on. Supposing somebody is a student with a medicine background, he will look at it from his own baggage. Okay, so, but now when you look at this Gaia hypothesis, you will see that all are related and we need to have a holistic approach. That means we should not say that, oh, I'm trained in discipline. You want to ask something?
Hello, Madan. Hello, Gaurav, Madan. Please mute all the mics.
Gaurav sir. Gaurav sir. Hello. Gaurav sir.
These two persons are disturbing us.
सर जो है रिक्वेस्ट है कि सबको वो कर दे, म्यूट कर दे, जैसे सवेरे किया था.
Yeah. Thank you. So the reason for looking at the Gaia hypothesis is that this is one justification for having integrated approach towards our knowledge. So when we say integrated approach, basically we divide the sciences into two groups. One is what you call as the natural sciences, and the others are called as the social sciences. So in natural sciences, you will have mathematics, physics, chemistry, and so on. And in social sciences, you could have anthropology, law, history, and so on. Okay, so now people with natural sciences background will think only from their perspective. Social sciences people will think only from their perspective. But there is one interesting area, which is economics, which is a sort of a bridge between both natural sciences as well as social sciences, because economics mainly deals with welfare of the people. So social science is important. But then the methodology, etc., they use is basically more of statistics, and calculus and so on for their different analysis and so on. So that is why economics is one field which probably belongs to both natural sciences as well as social sciences. So when we say that we have an integrated approach, it means that we have both the social sciences people as well as natural sciences people, along with economics, to work together in one group. Okay, so that is how we try to look at integrated approach towards problem solving. I'll come to that a little later. Now, if you look at the age, this is in million years, and probably geologists will be better in classifying this geologic age. Up to this around, let us say, the Meghalayan period. So you have the Quaternary Pleistocene, early, middle, and late. Then you have the Holocene, early, middle, and late. This geological age basically depends on the Earth crust. So depending upon the fossils, etc., people were able to tell what was the age of that state of Earth and so on. Okay. So roughly you have about this quaternary up to 2.58 million years, and up to this late Meghalayan Holocene period, it is all based on the Earth crust, which happened due to natural this thing like volcanic eruption or erosion and so on and so forth. But now this epoch is called as Anthropocene. So Anthropocene is for man-made. Okay, so now whatever you have in the Earth's crust is heavily influenced by the activities of humans. So that is why this period, let's say from the early industrial revolution period to now, we are living in this Anthropocene period. Okay. Now, there is another concept which is called as a Milankovitch cycle. So these days we talk about global warming and all, isn't it? So now this global warming has been happening, okay, for very long period. And the reason for this global warming and ice age is because of this three phenomena. That is, one is the orbit, that is the motion of the earth around, motion of the earth around the sun is elliptical orbit. Okay, but then there is a small change in the elliptical orbit, and that varies between 100,000 years to 4,100 years. Yeah. So, 400,000 years. So this is due to eccentricity. Then there is another phenomena that is due to the tilt. The tilt itself is changing, and a small variation between 21.5 degrees to 24.5 degrees tilt is happening in a cycle of 41,000 years. Okay. So currently we are having this tilt at 23.5 degrees, isn't it? So this tilt also is changing. And the last one is what you call as precision. That is the change that is occurring due to the wobbling motion. Yeah. So this wobbling motion is similar to the top. Yeah. So when you play the top, when it loses its energy, it will start wobbling. Yeah. So this wobbling action also takes place between 19 to 24,000 years. So all this, when you combine, you will get roughly cyclic changes, and that cyclic changes will result into this type of changes. Okay. So here you will see that, the changes in the temperature. So now this, you will have to read this graph from right to left. Yeah. So 0 is to the right. So age in 1,000 years before present. BP is for before present. Okay. So roughly you will see that you have ice age. Now presently we are in warmer age. Yeah. So you have the cooling, that is the ice age, then the warming, then cooling, then warming, and so on. So you'll see that these are all cyclic. And this have been, derived from the ice cores in Antarctica. And through that, through surrogate measurements, they have found out what would be the carbon dioxide concentration in the Earth's atmosphere. Okay. So you see here that it varies between roughly about 180 ppm to roughly about 300. So this is a cycle that keeps on happening. Okay. And if you look at the periodicity, this periodicity matches with the Milankovitch cycle. Yeah. So the Milankovitch cycle that we discussed earlier, yeah, this Milankovitch cycle. So this Milankovitch cycle, the maximum period is due to the change in the eccentricity. Okay. And now the other changes are, superposed, and you get a complex cyclic pattern that is happening in this fashion. Okay. So now we are at this
बाबू इधर बाबू
So we are in the warm period.
सोनू ए बाबड़ा
Okay. So now, if we focus a little more on this past age in 1,000 years, yeah, you will see that almost here in the Holocene period, the carbon dioxide concentration is almost constant, roughly around 270 or 280 ppm. And then the temperature is also almost constant. Just for there is a small dip which is called as a little ice age, and then you have the medieval warm period. And after this dip of the little ice age, you will see that there is a shooting up of the temperature. Then you see here what is happening to the sea level. Yeah. So roughly about 20,000 years back, yeah, the sea level was minus 125 meters. So that means you had more land about 20,000 years back. But in this Holocene period, this sea level is almost constant. Yeah. So that is our datum. 0 is corresponding to this horizontal period. Yeah. So this again, if you look back with the Gaia theory, yeah, what the Gaia theory says is that everything tries to come back to some equilibrium position. Yeah. So here you'll see that the sea level has come to equilibrium position. And that is why you'll see that life has flourished. Yeah. Similarly, the carbon dioxide. But this Milankovitch cycle does not explain what is happening after the industrial revolution. Yeah? So once you had the steam engine and so on coming into picture, yeah, there was a sudden change in the atmospheric carbon dioxide concentration. So it is rising at the rate of 1.6 parts per million per year. Yeah? So from this. So here you will see that now we have crossed about 420 ppm from an upper limit of about 300 in the pre-industrial carbon dioxide concentration. Okay. And what is happening to the global temperature? So global temperature has also increased by almost 1 degree Celsius. Okay. And then you will also see that almost about 0.3 meters, there is a sea level rise. Yeah. Now, we have to be careful, especially people who are staying in coastal areas, about this sea level rise. It is not only going to affect the coastal areas by flooding, it is also going to contaminate the groundwater due to seawater ingress and so on. Not only that, it has a bearing on the urban drainage system which are constructed in the cities. Let us say I was in Chennai. Now, if there is a change of 0.3 meters in the sea level at Chennai, then all my drainage systems will be affected because the terrain is flat and we may not be able to push the drainage into the sea. And probably that is one reason why you will find that many of the cities are getting flooded. May not be the only reason, but then you will see that because of the change in the sea level, you have problems due to drainage, you have problems due to seawater intrusion, then flooding and so on. Okay. So this is an important graph which talks about this sea level rise. Okay. Now, in addition to climate change, you have another phenomena which is called as urbanization. What is urbanization? It is nothing but increase in population. Not only increase in population, it is also increase in the population density. Okay. Okay. And then there is migration of people from rural area to urban areas. Okay. And because of which it has its own problems. Okay. Now, if you look at what is happening to, let's take our own country. When we had independence in 1947, roughly the population was about 40 crores. Now, what is the population? 140 crores. Yeah. That means we have increased by almost 3.5 times. Yeah? The population has increased tremendously.
There, Babu.
If you look at the changes that have taken place, mainly in this area, for the past 100, 150 years, the population has increased tremendously, roughly from about 1 billion to about now around 7. Now,
31.
reasons that have been
Rule
attributed.
number 31. Ganesh Vanuj. You please mute your mic. इधर ना.
Can I continue? Yeah, thank you. So there are many reasons why populations have grown rapidly.
पण पुन्हा यावं लागेल लावायला. कुणाची गाडी आहे ही? हा? अशी लावूया.
नको sir.
Yeah, sir, is it possible to mute the participants except the speaker?
Yes, sir. I'm just trying for that only. Because
Yeah.
mostly from the HRDC.
No, I understand their difficulty also because they have been sitting from morning.
No, it is not their difficulty. It is their rule. They have to be because this course is mandatory for them.
Yeah, but then they should exercise some caution. Please.
Sir, I request
येऊ दे.
respected Bandela sir, please make me co-host. I can mute them meanwhile when they disturb us. Sir, Bandela sir.
Sir.
Can you make me co-host?
Yeah, no, this is from the HRDC. There it is there. I'm just so it is not in my computer only. I'm trying
Okay.
Just 2 minutes, give me.
Yeah. So thank you. So now, why is this population boom that is taking place?
बघा.
It's mainly because of the major scientific and medical.
Sir, sorry to interrupt.
Yeah.
Just I will mute everyone. Then again you unmute yourself, sir.
Yeah, sure.
Sorry for interruptions.
No problem.
Now you can unmute yourself, sir.
Yeah, I'm unmuted.
Yes.
Am I audible, sir?
Yes, sir, you're audible.
Yeah, thank you. Yeah. So now, if you look at why this population growth has, exponentially grown, is mainly because of the scientific and medical advances. Yeah. So, and when you talk about scientific advances, it's mainly because of the artificial fertilizer, which was advanced through this Haber-Bosch process. After that, we had more food. Not only that, because of the scientific revolution, yeah, you had more comfort, transport improved, and so on. So there are a lot of good things that have happened due to scientific revolution, and that is the reason why population has grown. So we hear a lot of elderly people saying that our time was good and so on and so forth, isn't it? Maybe in a limited way, what they say is right, but then definitely the present age, I would consider to be much, much, much better than what our forefathers enjoyed. Yeah. Just to give an example, now I'm able to talk to you through this technology, sitting hundreds or thousands of kilometers away, which was not possible even, let's say, about 20 or 30 years back. Yeah. So you have the climate in your office and the home controlled through the air conditioners, the fans, the locomotives, the cars, and so on. And things are improving every time. Yeah. So now we used the fossil fuel, then we understood that fossil fuel is no more going to last, and then it is not a sustainable this thing. No, people have moved to renewable energy sources. Now you have this electric vehicles, yeah, solar energy, and so on. So that is what, again, it's the Gaia hypothesis. Yeah. Human intelligence also tries to help in assisting life, I would say. Yeah. So that is the reason why you will see that population is growing. Nutrition. Yeah. So today's people are enjoying much better nutrition compared to earlier days. So because of all this, you will see that, yeah, this is why, yeah, this area, there is population growth. Yeah. And the recent example of the pandemic, COVID, yeah, we all escaped. Of course, there were some deaths, but then it was not anything compared to the earlier plagues that were witnessed, yeah, just after the World War. Okay, that is because of the improvement in technology. Yeah, people were able to, simulate vaccines and then mass produce, and people were, saved. So, and if this continues in a very short period, the population is expected to reach 10 billion. Now, with this, it has its own problems. What are the problems that we face? Is that Yeah, so you will see here that this green line is the urban population. Of course, this is for the world, and the blue line here is the population that in millions, and this is the food demand. So you will see here that again, the food demand is growing exponentially. So food demand in thousands of tons. That is what is the thing. Okay. So now you will see that this twin problems of urbanization and climate change are putting more pressure on our resources. Now, sometimes I used to jocularly tell my students that climate change or global warming is similar to blood pressure. Yeah. It is constantly there. Yeah. And urbanization is something like obesity, sudden growth. Yeah. So now, whether obesity is the cause for blood pressure or blood pressure is the cause for obesity, we don't know, or maybe they are interlinked. Similarly, whether this global warming and urbanization are interlinked, we don't know. Maybe they are interlinked. And on a longer range, maybe they are not when we look at the Milankovitch cycle. But in a short range of the Anthropocene, this thing where the rate at which the warming is taking place, you will see that both are related. And hence, you will see that urban areas are facing their own problems like urban heat island and so on. Okay, that is again because of this global warming at the local level that is, impacting the urban areas. So now, what are the challenges that are faced due to this twin problems of urbanization and global warming is that there is an increased water demand for food production. So you have more mouths to feed. That is why you need more food. So not only more mouths to feed for humans, you also have cattle. Okay, you have the other this thing like people who take meat. Yeah, so for them also you need water. Yeah, okay. So the challenge is how do we meet the increased demand from the existing resources? Now here I would like to slightly bring to your notice that what is happening due to climate change. Yeah. Now, we will be talking about this hydrologic cycle. Okay? So what happens is that when there is an increase in the temperature, it means that there is an increase in the energy levels. So this hydrologic cycle also gets accelerated. Yeah, it is like I'm cycling. Okay, when I'm fresh and immediately after my breakfast, if I take the cycle, I'll be pedaling fast. That is because I have more energy. Now, after I finish my half day's work and then go back home on the cycle, I will not be pedaling as fast as in the morning because my energy levels are low. So what is happening is now, because of the global warming, the energy in the system is high, and that is what is accelerating the water cycle. And because of which you will find that at some places there is a intense rainfall, and at some places there is no rainfall, which means that earlier when you had, let us say before the global warming, the number of rainy days used to be large, and the period between the rainy days was less. Now what is happening is that the number of rainy days has reduced, and then the period between rainy days has increased, which means that during the same period, why same period? Within the given year, you could have the problem of both flood and drought. And this was seen some time back, probably in 2018 in Kerala. Yeah, we had heavy floods, and during the same year, we had drought-like situation. Yeah. So because of this global warming, we have high intensity rainfall, and then the period between the rainfall has increased. So now this gives rise to more problems. Like, how are you going to store the water for the non-rainy period? And because of which your cropping pattern changes. And that is why we now talk about what is called as a climate resilient crops. Yeah. So what are these climate resilient crops? These climate resilient crops are nothing but those crops which are able to adapt to this climate change. Yeah. So these are the problems. And because of the growth in science and technology, yeah, there is a greater demand for industry, and we need water for this industrial growth. So more water for power generation, higher effluent generation from industries. So if you have higher effluent, then you need to treat it. Yeah. So the challenges are effluent recycle and sludge disposal, increased water productivity, then adaptation of modern technology. Yeah. So this is from industry perspective. Then you have the domestic use of water. You have higher sewage generation, new source for water supply. We have to find prevention of wastage. That is where you have the 3 R's. Yeah. Reduce, recycle, and reuse. Yeah. Then this is a contentious issue, that is water pricing and metering, especially the Western countries, etc. They follow this water pricing and metering. But in our country, it is a very sensitive issue, because the public at large may not readily agree for water pricing and metering. Then you have this sewage treatment. So this is another thing. Yeah. So these are the challenges for the future. And that is why we have to manage our water resources in an integrated way. That is where this IWRM, or Integrated Water Resource Management, comes into picture, which is the need of the hour. Yeah. Just to give a rough estimate, although the water cycle has accelerated, on an average, if you look at the rainfall in a given river basin, is almost constant, which means the volume of water per year on an average. Let us say you take the rainfall data for the past 30 years and then do the statistical analysis. Although there are changes, but if you take on an average, it is going to remain almost constant. So now, let's say from independence, I told you that the population has become almost 3.5 times. Let's say that if you want to do a back of the envelope calculation, let us say the population has increased 3 times. Yeah. Now, not only the population has increased 3 times, your demand for water also has increased. That is because earlier, as per the CPHO manual, the rural area, we were providing water around 40 liters per capita per day. Yeah? Now, that has almost become 3 times now. So, the water that is provided for the the urban areas is almost 145 liters per capita per day. So you'll see here that again, the water requirement has increased. Okay. Now, more area under irrigation has come into picture. Yeah. So because of which you need more water for irrigation. So the water demand for irrigation, again, let us assume that it has become double. So what has happened? 3 times population. Okay. 3 times your water due to urbanization. And then you have doubling of the water that is required. Yeah. Then not only that, because of your lifestyle, yeah, you have water which is required for lawns, for washing your vehicles, air conditioning, etc. So that also puts an additional demand for water. Roughly, you will see that if you add all this, the water demand has almost increased by 10 times. Add to this, there is another problem which we call as artificial scarcity. Now, what is this artificial scarcity? This artificial scarcity is nothing but the water that is not usable due to pollution. Yeah. So now this pollution, as we see here that because of the sewage, etc., that is generated in the urban areas, again goes back to the water body. Yeah. And because of this pollution, that water is not usable. So almost 50% of the water bodies have become polluted, whether it is the surface water or the groundwater, both have got polluted. So you will see here that there is a lot of difficulty in water management. Yeah, because your resource is the same, but then your demand has increased. It is like, a family with the same income has grown. Earlier, 2 members family, let us say if the number of members become 10 times, but without additional resources, you can imagine what is the stress that is on the water resources management. So this is just one example where you can look at the challenges that are there for water management. Okay. Now, how is this concept of water resource management come about? Integrated water resources. Okay. So now, if you look at the history, in June 1992, there was a Earth Summit in Rio de Janeiro, yeah, in Brazil. And then more than 178 countries adopted this concept, which is called as Agenda 21. So what is this Agenda 21? It is nothing but a comprehensive plan of action to build a global partnership for sustainable development to improve human lives and protect the environment for the 21st century. So this 21 indicates 21st century. So Agenda 21. So the member states unanimously adopted the Millennium Declaration at the Millennium Summit in September 2000 at the UN headquarters in New York. So this led to what are called as Millennium Development Goals, that is to reduce the extreme poverty by 2015. So what happened was that we have crossed this 2015, isn't it? Now, during the Johannesburg meet on sustainable development, you had the World Summit on Sustainable Development in South Africa, which reaffirmed the commitment to Agenda 21. Okay. Then again, the United Nations Conference on Sustainable Development, which is called as Rio +20, met in June 21, and they came up with a document which is the future we want. And then this Rio +20 also contained other measures for implementing sustainable development, including mandates for future programs, financing small island development states, and more. And in 2013, there was a working group which came up with the Sustainable Development Goals. And again, in January 2015, there was a post-2015 development agenda, and these came up with the 17 Sustainable Development Goals. And this is a brief background for this sustainable development, how this have come about. Okay, and then there were a lot of multilateral agreements, and I have just briefly put them here. Yeah. Now, when we talk about integrated water resource management, and it is defined as a process which promotes coordinated development and management of water, land, and related resource in order to maximize economic and social welfare in an equitable manner without compromising the sustainability of vital ecosystems. Okay, so this was Global Water Partnership, which came up with this definition. There are a lot of critics about this definition itself. When you say promotes, question is who is going to promote? And when you say maximize economic and social welfare, so maximizing economic welfare has a different meaning than talking about social welfare, because social welfare does not look into the profit or loss, whereas economic maximization talks about the profitability. Yeah. Then when you say equitable manner, yeah. So what is this equitable manner? Yeah. Even in developed countries, the equitable yardsticks are different. In developing countries, the equitable yardsticks are different. Even within the same country, urban area and rural area, as I just told you, the water that is provided in urban areas is 140 liters per capita per day, whereas in rural areas, it is about 40 liters per capita per day. So there is no equity between water that is supplied between urban areas and rural areas. So when you say about equitable manner, now these are difficult questions. Okay. Now when you talk about sustainability of vital ecosystems, yeah. So what is the meaning of sustainability? Yeah. Now sustainability has different meanings. You can talk of sustainability only when the resources are renewable. And when the systems, the resources are non-renewable, for example, fossil fuels. You cannot talk about sustainability of fossil fuels. Okay. So renewable energy sources are solar energy, wave energy, wind energy. Yeah. Even water is considered as a renewable resource because every year we get water that is replenished due to rainfall. So all resources are not renewable, and only the renewable resources are sustainable. So Asit Biswas has, listed a lot of pros and cons about this definition itself. But then we say that this is a normative concept. Integrated water resource management is a normative concept. What is the meaning of normative concept? It is an ideal which we want to achieve. Yeah. It is like, for a religious person, it could be either going to heaven or achieving nirvana or achieving salvation. Nobody knows what is this nirvana, what is this salvation, what is this heaven. But we keep talking about it, isn't it? Yeah. And that is what you call as a normative concept. Okay. So most of our ethics and all are basically normative concept. So similarly, when we talk about IWRM is also a normative concept. So it is a goal, but then the goal is not important. It is the journey towards that goal which is important. Yeah. So that is why IWRM is an important concept. So now this IWRM has 4 basic principles which are known as the Dublin principles, which were adopted in an international conference in Dublin in 1992. Now let's look at these 4 important concepts. So the first concept is fresh water is finite and vulnerable resource, essential to sustain life, development, and the environment. Okay. So let's look at this first definition a little more carefully. It says that fresh water is finite, which means that it is limited. Yeah. And this is where you need to look at water budget. Yeah. And also it is a vulnerable resource, which means that it can be easily polluted. Yeah, vulnerable. And without water, life is not possible. Yeah, essential for sustaining life. And also development, that is for our own development and for the sustainability of the environment. So this first definition basically is built in with the hydrology concept, the hydrologic cycle, and so on. Okay. The second is water development and management should be based on participatory approach involving users, planners, and policymakers at all levels. So the second concept is basically talking about the stakeholders. Yeah, so here the social scientists come into picture, and you need to involve all the stakeholders. Yeah, right to the end. If you talk about providing water for agriculture, you will have to consider the farmer on the field and look at his views. Okay. So the second one basically talks about stakeholder participation. The third one is women play a central part in the provision, management, and safeguarding of water, which means that here we are talking about the importance of gender. Yeah. And you will find that in any household, it is the women who play a major role in managing the water. Even if you look at a field where, let us say, transplantation of rice is taking place. Yeah, you just take any picture. If you just Google for transplantation of rice, you will find that it is mainly the women laborers who are doing the transplantation. So the women's participation in labor, in agricultural activity is also there. They are also looking after the water management at household and so on. So that is why this gender becomes an important concept in the IWRM principles. Lastly, water has an economic value in all its competing uses. It should be recognized as an economic good. This is one contentious issue. If you accept it as an economic good, then it has to have a price. Lot of people say that, water, we get it naturally, why it should be priced? Yes, we do agree that water comes from the heavens, why it should be priced. As long as you are able to catch the water that is falling on your property and utilizing, no issues. But if you are taking water through municipal pipes and so on, it has to have a price. It needs to be collected, it has to be transported, it has to be treated. So there has to be a price for water. And unless we have this water pricing, we will continue to face mismanagement. Yeah. We will continue to face mismanagement because there is a saying, if the quality of water that is provided to you is not good, can you go and complain? Of course, you will say that the quality is bad, but whom are you going to complain? Because you are not paying for it. So your bargaining power reduces if you are a freeloader. Yeah. Supposing the water is given free to the farmer. Yeah. And if the power is given late night, he cannot complain because the government says that we are first going to give power to people who pay, and only during the slack hours we are going to provide people who are using it free. Yeah. So you cannot. So that is why there is a saying, beggars cannot be choosers. Okay. So by taking things free, we become beggars, and we cannot, rightfully ask for good quality of water or proper power for irrigation during daytime and so on. Okay. So unless we come to, value this water, we continue to face this problem. But then there is a dichotomy, or you will find the people readily paying 20 rupees for a bottled water, but then they are not ready to pay even 100 rupees for piped water. Yeah. So roughly the water pricing would work out to 5 rupees per kiloliter. Yeah. 1 kiloliter is 1000 liters. So if you put a meter and then if you are charged at 5 rupees per kiloliter, you will get better quality water. So unless we understand this, unless the water pricing is done, then we may not be able to provide good quality of water to the citizens. Yeah? So this is what we learn from other places. Yeah. So this is four important Dublin principles. Okay. So integrated water resource management is based on equitable and efficient management and sustainable use of water, and recognizes that water is integral part of the ecosystem, a natural resource, a social and economic good, whose quantity and quality determine the nature of its utilization. Okay. Okay, so this we have the general framework for IWRM. So you have the pillars here. So you have economic efficiency to social equity. Yeah. So if you look at the definition itself, here you have that maximize economic and social welfare. So here the bottom line is that economic efficiency also has to be there. And then you have to have social equity. Yeah. So the three pillars are enabling environment of suitable policies, strategies, and legislation for sustainable water resource development and management. Next is putting in place institutional framework through which to put into practice the policies, strategies, and legislation. Okay, setting up management instruments required by these institutions to do the job. So these are the three pillars of. So one is management instruments, second is enabling environment, and the third is institutional rules. Okay. So just to give one example of these institutional rules that are played, now I think now it's about 1.5 hours. Shall we take a 5 minutes break? Shall we take a 5-minute break? Hello? Bandela sir? Shall we take a 5-minute break and come back? Am I audible?
Yes, sir.
Yeah? Yeah.
Yes.
Yeah. So now it is about 4:30. So let's take about 5 to 7 minutes break and come back. Yeah? Fine. Hello. Hello. Shall we start?
Yes, sir.
Yeah. Yeah. Are there any questions till now? Anybody?
Yes, sir.
Yeah, go ahead. Okay. So let's look at this IWRing planning cycle.
Any question? No, sir.
Yeah. Hello. Yeah. So you can start this cycle from here. Establish state, okay, and overall goals. So when you say establish status and overall goals, is that what is the present condition and then what you want to achieve. So that is the establish the status and you have to state what are the overall goals. Next is build a commitment to reform the process. Then analyze gaps, prepare strategy and action plan. Yeah. So this is what is important, that when you say that when you have action plan, then what are your targets? What are your goals? Okay. Then build commitment to actions, implement frameworks, and finally you have monitor and evaluate the program. Yeah. So based on this monitoring and evaluation, you can give feedback at what stage you need more intervention and so on, so as to achieve the targets. Okay. So here you have that stakeholders are given a voice in water planning and management with particular attention to securing involvement of women and the poor. Okay, so basically when you start with what you call as the baseline study. Okay, so establish the statuses. in many these things we call them as baseline studies. And when you have the baseline study, the first thing that you need to do is you need to know what is the present condition. And that is not only through reports, etc., you need to interact with the concerned people. Okay. So that is what we call as stakeholder interaction. Now, the stakeholders could be different types of stakeholders, what we call as a primary stakeholder. We also have what are called as secondary stakeholders. Then we also have some people who are called as key informants. Okay, so these three important words you keep in mind: primary, secondary, and key informants. These days in the literature, instead of the word stakeholder, they use the word actors. Okay, so key actors, primary, secondary, and then you have key informants. Okay. Now, what is the difference between a primary stakeholder and a secondary stakeholder and a key informant? To give an example, let us say that you have this, let us take this example of providing water to the farm. Now, who is the primary stakeholder? It is the farmer. Okay, so farmer is the primary. Going to sell it. So the merchant becomes the secondary stakeholder. Now, you also have people who provide water to the farm. It could be the irrigation department, etc. They are also primary stakeholders. Now, who are the key informants? Key informants are the people who are knowledgeable but are not affected by the outcome. Yeah. For example, there could be a official let's say a school headmaster, yeah, or a school teacher. School teacher is not going to be, so much affected by whether the water reaches the farmer or no, because he does some other work and he gets paid for that. But since he is living in that environment, he is knowledgeable about that. So you can also interact with that person to get some unbiased opinion. Okay, so they are the key informants. So primary stakeholder, secondary stakeholder, and key informants are important. So you need to give them a voice. Okay, then you also have to see that the stakeholders also are made up of the marginalized people who are poor, and the gender equity comes into picture. Women also have to participate. Okay, so policies and priorities consider water resources implications, including the two-way relationship between macroeconomic policies and water development and management and use. Now, most important concept is that all these decisions are made at local and basin levels. Yeah. So when you talk about water resource management, we use either the basin or the sub-basin as the unit of management. Okay. And water planning and strategies are incorporated into broader social, economic, and environmental goals. Okay, so what is it that you're going to achieve? Now, these days, the problem is that you have catchments that are closed. What is the meaning of catchments that are closed? It means that there is a gap between demand and supply. That means if the demand is more than the supply, then such a catchment is called as a closed catchment. To give an example, let us take any urban catchment, let us say Chennai. So for the population of Chennai, to provide for the domestic, industrial, etc. water, the rainfall that is coming in the Chennai basin is not sufficient. Yeah, that is why we call such a basin as a closed basin. Now, what do you do to address this problem? You need to import water. Yeah. So that is why you will see that specifically for a place like Chennai, we get water from a faraway place called as Viranam. So Viranam gives water to Chennai, but then Viranam is part of Kaveri Basin. So it is not part of the Chennai Basin, either the Adyar, the Kosastaliyar or the Kuam. So you are getting inter-basin water transfer. Yeah. So water is coming from another basin. So you are importing water. Or the other source for Chennai is the water that is coming from the Krishna basin, the Krishna water, the so-called Telugu Ganga project also supplies water for drinking purposes to Chennai. So you have another this thing. These days you will see that a lot of desalination plants are coming up. Okay, there is a lot of criticism about desalination plants, its effluents and so on. But then what is the alternative? Yeah. And the other thing that we need to keep in mind is that the more we use the technology, the more refined it becomes. So the prices of desalination are keeping on falling. And also the technology is improving. Well, the criticisms are valid, but then we also need to address those criticisms. Okay, and take proper care so as to not to unduly overload the system. Okay, so that is okay. I have also talked about this increasing population, living standards, artificial scarcity, etc. Now you will see that many areas are involved in this water resource management. You have economics, you have agriculture, you have meteorology, hydrology, sociology, other disciplines, legal, and so on. Yeah. To give an example of legal, you will see that our groundwater depletion is very rapid in many parts of the country, especially the three most affected areas are Punjab, Haryana, and Tamil Nadu, where the groundwater levels are depleting alarmingly. Now, why is that happening? It is because there is no law to control the borewell numbers, their size, and so on. Yeah. That is because of one pre-independent time law, which is called as the Indian Easement Act of 1883. It means that the law says that whoever owns a parcel of land has absolute right to utilize it. So supposing I have a land in my name, then the Indian Easement Act gives me the freedom to put a borewell as large as possible, as large as my pocket permits. And hence, you will see that there is a proliferation of these borewells and there is a problem of this depletion of groundwater. Now, in 1883, there were hardly any electricity. There was no pumping technology. The population was also less. Probably during those times, one crop per year would feed all the mouths. And hence, during those periods, it was not necessary to put a curb on the wells that is being dug and so on. But today what is happening is that we need to have legislation. And that is why many of the states are drafting their or have already drafted legislation to control the bore wells that are being put into different areas. Okay. So this is one example where law comes into picture when you are doing water resource management. Okay. So we need to look at various disciplines that, are involved in water resource management. And that is why integrated approach is important. You need to have a team with people who understand economics, who understand agriculture, who deal with meteorology, hydrology, hydraulics. Yeah, for example, constructing a dam or canal system, etc. And other disciplines like law, sociology, and so on. Okay. So this is the thing. Now, this is a very, I say, a descriptive picture where we all study in our school about the blind men when they are asked to describe the elephant. So when a person touches the ear, then he will say that it is like a mat. The other blind person, when he touches the trunk, he says that it is like a snake. The other one touching the tusk, it's like a sphere and so on. Somebody touching the leg will say it is like a trunk of the tree. Somebody touching the abdomen will say it is like a wall. The tail is like a rope and so on. Okay. So each of the blind men with their own understanding will say what it is. Yeah. Similarly, we are also like blind men. Yeah. Although we may be, studying different areas. Yeah. We may be environmental engineers. We may be civil engineers, mechanical engineers, or sociologists, economists. We have our own baggage. And with that baggage, if we try to describe a problem, it is like the blind man trying to describe the elephant. So we don't get the holistic picture. Only when all of them put together, they come with an integrated thing, then you get a rough idea about the problem. Yeah. Okay, so I have talked about this normative concept and sustainable development. So let me skip this. So water cycle, we all know, we have studied. Yeah. And you have the different components of the water cycle. Yeah. And as I told you that the water cycle gets accelerated due to the climate change. So warmer the climate, more rapid is the cycle. Yeah. Now, there is a difference between the urban areas and the rural areas. Now, the problem is that before urbanization, we'll see that there is a better distribution of the resource, that is groundwater, evaporation, and so on. But then when you have urbanization, you'll see that the water table falls. Yeah. Less amount of water gets to the groundwater. Okay. And then you have pollution, which is coming to the surface waters and so on. Okay. So these are the implications of urbanization on the water cycle. Now, let's come to the topic about water, energy, and food nexus. Now, these are related to the Sustainable Development Goals. Yeah. So now, what are these Sustainable Development Goals? We have already seen. Totally, there are about 17 Sustainable Development Goals, and all these are interlinked. And the first and the 17th goals are common. That means they are what are called as overarching goals. Overarching means they cover the other goals also. So these are called as overarching goals. So the first goal is no poverty. Yeah. So when you say no poverty, it means that the per capita income of a person should be sufficient so as to have a decent living. Yeah. But then this is best decided by the sociologists and the economists. They will be able to better tell what should be the amount of money that a person should be able to earn and so on. And because of this, you will find that in developed countries, for example, in US, you have the hourly rate for the wages. Yeah. Yeah, something like $10 or $12 per hour is the wages there. Okay. So a person who is doing labor on hourly basis will be able to earn that much amount of money. Supposing I go to US as a student and let us say that I'm in difficulty and I'm working, let us say as a in a petrol bunk or somewhere, I will be earning about, or in a cafeteria, then $10 to $12 per hour will be my earning there, which should be good enough for a decent living. Now, the other one is that you need to have the partnerships for the goals. Yeah. So the partnerships with different institutions like the funding agencies and so on, the implementing agencies, the so-called institutions. These are the partnerships that need to be developed. Okay, for each of these goals, you will have different institutional frameworks. Now, for us, three important goals are, one is zero hunger, because that is related to food. Yeah. Then the sixth one is clean water and sanitation. Yeah. Clean water and sanitation. So that is water. So water and food. The third one is energy, which is goal number 77. So which is affordable and clean energy. So 2, 6, 7 are the goals that we are looking at from water, energy, food nexus. Now, these days, you will see that there is another this thing which is added, which is ecology. Okay. So now, where does ecology come into picture? You don't have a separate this thing for ecology, but then it is built in all this life on land. If you take, that is also ecology. Life below water, that is also ecology. So this is how you have different goals that are this thing. So this sustainable development goals we are supposed to achieve. And in the words of the previous Secretary General Ban Ki-moon, the 17 sustainable development goals are our shared vision of humanity and a social contract between the world's leaders and the people. Yeah. So the world leaders gather and then they sign that, okay, we are going to implement these sustainable development goals. Fine. Now, all these are interlinked. Yeah. So you will see that gender equality, quality education. So all the 17 goals are listed on the periphery. Okay. So you have the main this thing that zero hunger is related to what are the different types of this thing. Yeah. So it is related to clean water. Then you have affordable energy. Yeah? So there is a linkage between these SDGs. Okay. So no goal is an isolated goal. Yeah? So all are interlinked. Now, different regions have different areas which can be vulnerable. For example, the Himalayan region is vulnerable to climate change because of the glaciers, ice melting, and so on. Now, this Himalayan region is a feed for many of the rivers, right from Pakistan, India, China, Nepal, Bhutan, and Bangladesh, Myanmar, Thailand, and so on. So you'll see here that there is a strong linkage between the different countries and what happens to these areas. For example, deforestation in the Himalayas could affect the flora, the fauna, the biodiversity, the amount of water that is flowing down. Yeah, it could create flash floods. For example, the river Kosi is known for creating flooding. Yeah, so these are the problems that you see. And you will see that we say that the problems of water are problems without boundary. Yeah, because water is going to flow. It is not going to respect the boundaries or the walls. So the water that flows from, let us say, the Tibetan plateau, it will flow through India and then flow through Bangladesh, etc. So the problem in Tibetan plateau could be the problem for India as well as for Bangladesh. So the downstream people can get affected due to the activities on the upstream. Yeah, so that is what is shown in the second picture here. And you will see here that there is a nexus. Nexus is nothing but interlinkage between food, energy, water, and the ecosystem. So all are interlinked here. Okay. Now, as I told you, that each of the goals have what are called as targets, and the other ones are indicators. Yeah? So let us say that you are practicing shooting. So you have a goal. That means there is a target that is fixed. Yeah. And then you are trying to shoot. Now, what is your this thing? Your aim is to hit the bullseye. Okay. So now what are the indicators? The indicators are, let us say you shoot 5 bullets. How many have hit the bullseye or how many have not hit the bullseye? So that gives the indicator. Based on that, what you will say? That you will say that, okay, you are a good shooter or no. Yeah. So it is just like that. So every goal has targets, and to tell whether those targets are achieved or no, you have what are called as indicators. Now these indicators will be different for different goals. For some goals, the indicators could be quantitative, and for some other goals, the indicators could be qualitative. Okay. So now these indicators have to be simple. They need to be measurable. Okay. And they need to be done periodically. It is not that once you do it, no. You need to keep monitoring it at different times. So that is what is the use of these indicators. Okay, so keeping that in mind, let us talk about the food. The food goal is end hunger, achieve food security, and improved nutrition, and promote sustainable agriculture. So this is the goal. So one is to end hunger, then achieve food security, improve nutrition, and promote sustainable agriculture. Okay. Now, what are the targets? There are a number of targets. We'll go one by one. Now, for SDGs, the target year is 2030. So, end hunger and ensure access by all people, in particular poor and people in vulnerable situations, including infants, to safe, nutritious, and sufficient food all year. Now, indicators are prevalence of undernourishment. Okay. So, prevalence of moderate or severe food insecurity in the population based on the food insecurity experience scale. So, this is a scale which is going to measure the undernourishment. Then, by 2030, end all forms of malnutrition, including achieving by 2025 the internationally agreed targets on stunting and wasting in children under 5 years of age, and address the nutritional need of adolescent girls, pregnant and lactating women, and older persons. So this prevalence of stunting, that is height for age, now the standard deviation from the median should be less than -2. Okay. So various these things are given indicators. So you have 2.2.1, 2.2.2. So weight for height should be greater than +2 or less than -2 standard deviation. So we assume here that all these indicators have normal distribution. Okay. So when you say normal distribution, now you are doing a monitoring and evaluation. Okay. So when you do a monitoring and evaluation, you will have to collect samples. Now the thing is that how do you collect the samples? Okay. So now this sample collection is based on the demography. Okay. What are the population sizes in the different age groups, different economic strata, urban, rural, and different economic status I told. So based on this, the samples have to be collected. Now the next important thing is that how many samples have to be collected to be statistically significant. Okay, so statistics becomes an important criteria here. And then we assume that these distributions will be normal distribution. That is why we talk about standard deviation from the median. Okay, of the same. Yeah. So then by 2030, double the agricultural productivity and incomes of small scale food producers. That is what our government also aims, that we need to double agricultural productivity and income. So, and incomes of small scale food producers, in particular women, indigenous people, farmers, pastoralists, and fishers, including to secure and equal access to land, other productive resources and inputs, knowledge, financial services, markets, and opportunities for value addition and non-farm employment. What are the indicators? Volume of production per labor unit by classes of farming, pastoral, or forestry enterprise. Then average income of small scale food producers, and by sex and indigenous status. So these are the indicators. Then 2.4, ensure sustainable food production system and implement resilient agricultural practices. Yeah. So we also talked about this climate resilient crops. No? So this climate resilient crops should be able to increase productivity and production that help maintain ecosystems, that strengthen capacity for adaptation to climate change, extreme weather, drought, flooding, and other disasters, and that progressively improve land and soil quality. So proportion of agricultural area under productive and sustainable agriculture. So what is the area under which the productive and sustainable agriculture is practiced? So this is the indicator. Then maintain genetic diversity of seeds. Yeah. So these days, there is a talk about genetic diversity of seeds because many of these, what are called as these seeds which are sold by corporations like Monsanto and all, they are not having genetic diversity. Yeah. So cultivated plants and farmed domesticated animals and their related wild species, including through soundly managed and diversified seeds, plant banks, national, regional, and international levels, promote access and fair and equitable sharing of benefits arising from utilization of genetic resources. That means we have to go away from this bio-modified seeds, etc. Okay. Then number of plants and animal genetic resources for food and agriculture secured in either long, medium, or long-term conservation facilities. Proportion of local breeds classified as being risk, not at risk, or at unknown levels of risk of extinction. Okay. So you will see here that some of these indicators are quite difficult to measure. Yeah. Then you have other targets like 2A, 2B, and 2C. Now here you have increase in investment, then correct and prevent trade restrictions and distortion in world agricultural markets, adopt measures to ensure proper functioning of food commodity and markets. Yeah. So not only the farmer grows, he also need to sell it. Yeah. And for that, you need to have investments that need to be made for proper infrastructure. For example, if I grow vegetables or fruits, then what do I need? I need cold storages. Okay. And then I need proper, what you call transport facilities and so on. So for that, there has to be investment that need to be made, and then there need to be what you call as proper infrastructure and institutional support. Okay, so that is the indicators. Then the second one is producer support estimate, agricultural export subsidies. Yeah. So now what happens is that not all areas have conducive condition for growing crops. Okay. In some areas, we may be able to grow a certain type of crop depending upon the local environment, yeah, or the local climate. For example, we may be able to grow rice in southern part of India. whereas in the northern part, generally you grow wheat. So now the agricultural export has to take place between these two places. So there has to be support for that. So export subsidies have to be there, so as to see that there is a proper distribution of this agricultural produce. Now, adopt measures to ensure proper functioning of food commodity markets. So controlling the market is another problem which the government has to grapple with. So indicator of food price anomalies. Yeah. So whether the food price is increasing or decreasing, whether people are able to afford it. Yeah. So you can, just like you had artificial scarcity of water, there can be artificial scarcity of food. So there may be food in the godowns, but I may not have money in my pocket to buy the food. So that is an indicator of artificial food scarcity. And here the social network support from the government becomes important, where minimum food or food grains are provided so that people are able to get nutrition. Okay, so this food price anomalies are also to be taken care of. Okay, so you'll see here that a lot of these indicators are, some are measurable, some are quantitative, some are qualitative, and all these have to be, done at the field level. Then what is the number of samples that you are going to collect is dependent on the population, the so-called, what you call this, demography, yeah, and so on. And then you make assumptions that the distribution or this thing is Gaussian distribution or normal distribution. Then you do the statistical analysis and then say that whether the indicator has this value, and then you say that the target has been reached. You say sometimes 50% target is reached, 60% target is reached, or 100% target is reached. And since this monitoring and evaluation is a continuous process to assess whether the targets are reached, these indicators also need to be collected at regular intervals. Now let's look at this water. So achieve universal and equitable access to safe and affordable drinking water. Now proportion of the population using safe and managed drinking water services is the indicator. Then you'll see that most of the time it is the proportion of the population. Yeah. So achieve adequate and equitable sanitation and hygiene. Yeah. So when you have drinking water, it is also linked. So rule 6 is linked to water and sanitation. Okay. Then how you're going to reduce the pollution, then substantially increase the water use efficiency, especially in agriculture. Yeah? Because more than 70% of the water is utilized for agriculture. Even a small percentage of saving in agriculture is going to support other areas like domestic water supply or industrial water supply. Yeah? So these are many of the targets that have been given here. Then implement integrated water resource management at all levels. Yeah. So SDG 6 through 6.5 says that you need to have IWRM, including transboundary cooperation as appropriate. Yeah. So we have seen that map where the Himalayan waters Yeah? Flow through many countries. Yeah. So here you have that IC mode. Yeah. So you will see that India is involved, Pakistan, Afghanistan, China, Bhutan, Nepal, Bangladesh, Myanmar, so on. Yeah. So just only this Ganga Brahmaputra, this thing itself, you will see that many of the basins are involved. Okay. So now when water crosses national boundary, then such waters are called as trans-boundary waters. So when you say trans-boundary, it is between two countries. Okay. So for example, the northern, let us say you have the waters that flow through Punjab and Pakistan, they are trans-boundary problems. Okay. Similarly, the waters that flow through Nepal, India, and Bangladesh are trans-boundary. The waters that flow through Brahmaputra is again trans-boundary. So these are, for this, we need to have cooperation between countries. So there have to be treaties. Now, the best example of treaties is, let us take this example of Nile River. Okay. So this Nile River is in Africa, yeah, in the eastern part of Africa. Places like Kenya, Ethiopia, then this Rwanda, etc. Sorry, not Rwanda, Kenya, Africa, Uganda. These are the areas where rainfall is high. So these are what are called as the water towers of Nile River. So these countries, Uganda, Kenya, Ethiopia, are called as water towers of Nile River. So Nile has two branches. One is the White Nile, which comes from Uganda, from Lake Victoria, etc. And the other one is the Blue Nile, which originates in Lake Tana from Ethiopia, and then joins in Sudan, in the capital, near the capital city of Khartoum. Then it flows as one river through Sudan and Egypt and discharge into the Mediterranean. Now, during the British rule, sometime probably in 1920s or so, there was a Nile water sharing agreement. And what did the Nile water sharing agreement give? It gave more than 50% rights, water rights to Egypt, and about 20 or 25% to Sudan. I don't exactly remember the numbers, but then roughly you can say that around 25% to this thing. And then the remaining was for losses, yeah, evaporation loss, etc. The countries which were feeding the Nile River had no rights. So this gave rise to a lot of conflict, especially between countries like Ethiopia and Egypt. And I think after 50 years or so, new agreements have to be drawn. So roughly all the treaties of river water sharing have to be renegotiated after 50 years. So this is what you have as a trans-boundary water problem. Okay. Now, within the same country, if you are sharing water between two states, interstate water problems, yeah. Let us say the Krishna water is shared between Maharashtra, Karnataka, Andhra Pradesh, yeah. So this will become interbasin water. Yeah, so interbasin. So you have transboundary, interbasin, and there is another term which is called as intrabasin. And what is this intrabasin? Within the same state, if you are transferring water from one sub-basin to the other sub-basin within the main basin, then it is the intra-basin water transfer. So all these have to have management, yeah, proper management have to be there. And for sure, no two countries will agree fully. Yeah, no two countries will agree fully. And all these disputes are settled in the International Court of Law in The Hague. Okay. And normally, not more than 2 or 3 years, these disputes are settled. Okay. So let us say that we have a problem of water sharing with the two countries. Then what happens is that at the international court, there are experts from the two countries, plus they have their own experts. The international court also has its own experts, and then they will, get the data, verify the facts, and then depending upon the policy, they will try to settle the disputes. Now, why the disputes arise is because of the laws. Okay. So the laws basically here are two. One is what is called as a riparian right. The other one is called as the appropriation right, prior appropriation. So what happens is that, let us take this case of Egypt. So Egypt had a prior appropriation right. Okay, that means it was using water from beginning. Then it will say that since I'm using this water from beginning, I'm entitled for this share. The other right is the riparian right. That means if you are adjoining the water body, then you have a right to use that. So the upstream nations like Kenya and Ethiopia and this Uganda, they have what you call as riparian rights, because that is where the river is originating and flowing through. So because of the riparian rights, now there is a tussle between riparian rights and prior appropriation rights. And that is where most of the problems are. So unless these are settled amicably, there is going to be a conflict everywhere. So it could be between two nations, it could be between two states. Within the same state, it could be between two districts, or within the same town between two neighbors. So water sharing can be from household to international level. So, but cooperation is important. Okay. So I think I have described this problem of water sharing in great detail. So proportion of transbasin area with an operational arrangement for water cooperation. Then you have protect and restore water related ecosystems. Yeah. So including mountains, forests, wetlands, rivers, aquifers, and lakes. So now you have this new field of study which is called as eco-hydrology. Yeah. So which deals with all this type of this thing. Okay. So then expand international cooperation by capacity building, support to developing countries in water and sanitation related activities and programs, including water harvesting, desalination, water efficiency, treatment of wastewater, recycling, reuse. So amount of water and sanitation related to official development assistance, that is part of government coordinated spending plan. So how much of money is spent for these programs? Yeah. So one indicator is that how much of money is spent. So you do the allocation. After every year, you see how much of money is spent, whether the targets have been reached or not. Okay. So support and strengthen participation of local communities. So this is a community participation, which is a stakeholders participation. Then you have energy. Yeah. So you have the third important this thing, which is energy. So ensure universal access to affordable, reliable, and modern energy services. Okay. So one of the indicators of progress is that how much of electricity is consumed. Okay. Then proportion of population with primary reliance on clean fuels and technology. Then increase substantially share of renewable energy. So that is why government is giving a lot of push for using this renewable energy, be it solar, wave energy, or wind energy, and so on. Okay. So double the global rate of improvement in energy efficiency. So energy intensity measured in terms of primary energy and gross domestic product. Okay. So by 2030, enhance international cooperation to facilitate access to clean energy research and technology, including renewable energy, energy efficiency, and advanced cleaner fossil fuel technology, and promote investment in energy infrastructure. And okay. So how much money is mobilized per year starting from 2020? So what is the commitment? Then the last target for energy is expand infrastructure and upgrade technology for supplying modern and sustainable energy services for all in developing countries, in particular least developed countries, small island developing states, and landlocked developing countries in accordance with their respective programs. So how much is the efficiency as percentage of GDP is the indicator. Okay. So the amount of money allocated and spent, okay, for infrastructure and technology. So you will see here that for all the 17 goals, there are targets and there are indicators. And as I told you that some of the indicators are measurable, some of the indicators are quantitative, some of the indicators are qualitative. So different methodologies are involved in collecting data about the indicators, and that is done through a challenging activity which is called as monitoring and evaluation. So if you look at any of the programs which are large, they have a component of monitoring and evaluation. Okay. Why go that far? Even in our studies, there is monitoring and evaluation. In the class, we are monitored and then we are evaluated. Okay, how much of it we have understood or know, either through theory or through practicals and so on. So monitoring and these monitoring and evaluation have their own methodology. Okay. So there are what are called as toolkits which have been evaluated for monitoring and evaluation. For example, if you want to do a monitoring and evaluation for, let us say, improved agriculture. Okay. So there is a toolkit that has been developed and there are indicators which will tell how much of targets have been achieved or not. Okay. So this is a challenge. Okay. Now, are there any questions? I think we have covered about this water, energy, and food nexus. Okay. And all these are interlinked. So just to give an example, how water, food and energy are interlinked. Let us say that you have a agriculture field, okay? And in this agriculture field, you have been traditionally growing, let us say, paddy, okay? And roughly 1 meter depth of water is required to grow the paddy crop, yeah? And let us say that you want to save water. Now, there are technologies like alternate wetting and drying technology. So if you adopt that, then there are challenges like you will have to look at the weed problem and so on. Then more effort is required. So the farmer doesn't want to go into this alternate wet and dry method of paddy cultivation. Okay. It is also called as a rice intensification method. Okay, so they don't want to do that. Now, let us say that you change the crop. Instead of growing paddy, let us say that you grow some other crop which consumes less water, and less water indicates that your energy requirement is also reduced. So there is saving in water, there is saving in energy, and maybe you are able to get better remuneration for your produce. Okay, so there is a strong linkage between energy, food, and water. Yeah, let us say that you grow millets. Okay, so millets are consuming less water. They are also more nutrition, so better health and so on. So if you want to save water, one of the methods of saving water is what you call as crop diversification. So when you do the crop diversification, you will be able to achieve saving in water, saving in energy, and you have better nutritious food. Okay, so that is how, yeah. So just by changing the cropping pattern, these things can be achieved. So that is where you have a strong linkage between water, energy, and food. So this water food nexus approach, it was first consumed in the World Economic Forum not long back in 2011 to promote the inseparable links between the use of resources to provide basic and universal rights to food, water, and energy security. So an example of this exists in Northwest India, yeah, where intensive agriculture has been driven by government policies to support national food welfare. Unfortunately, these policies have degraded the ecosystem without increasing the levels of food security. So when we say Northwest India, it is parts of this Haryana and Punjab. What is the problem? The problem is the degradation of ecosystem is due to what? It is due to the increase in the water table and salinity. Okay, so which is going to affect the soil health and in turn reduce the yield. Okay, so although there was a government policy to support, but then you will see that it can have an adverse effect. So the intention may be good, but then the outcome, now we'll have to think about how to rectify it or improve that. Okay. So this is one example that is there. Okay. Then we'll see here that environmental sustainability is through water, food, and energy. Then livelihood, vulnerability, outcomes, and assets. So you have the sustainability as the intersection between these two. So environmental and livelihood security will be there if you try to intersect these two. Yeah. So you have the human demand, you have the natural supply, then you will have to balance this. So now most of the management has to be supply based, not demand based, because the demand is going to increase, but then the availability is restricted. That is why you have to have supply based management. Okay. This is another picture which shows the interlinkage between food, water, energy, and livelihoods. Okay. Okay, so now another way of looking at it in flow diagram is that you have water. It could be the groundwater or the melting of the snow. Then you have the source for all water is precipitation. From precipitation is rainfall. From this, it could be snowpack, or it can go as infiltration into the groundwater. And then this would be also surface water. Then you have treatment, then abstraction. Abstraction is taking water for either irrigation or for drinking water, and then so on. Okay. And where does all this water come from? It comes from the oceans. Okay. So the solar energy is going to hit the sea surface, and then evaporation takes place. And then, as you recall, in the water cycle or the hydrologic cycle, basically this is. Then this water is given for agriculture. And then you have a concept which is called as virtual water. Okay. Now, what is this virtual water? Virtual water is nothing but the water that is imbibed in a product. Imbibed in a product means, let us say that you grow paddy. As I told you that 1 meter depth of water is required to grow the paddy. Yeah. Now, if I take that water from the rice growing area, and let us say that I export it to areas like Middle East, yeah, where there is no rainfall and it is only sand and nothing can be grown. So it means that the water that is required for growing, for packaging, for transporting, if you add all that into that product and when you take it to the market in the target area, that water is called as a virtual water. Yeah, so you understand what is virtual water? So when you drink a cup of coffee, roughly about 30 liters of water is included in that, or the virtual water in a cup of coffee is about 30 liters. Whereas if you drink a cup of tea, then the virtual water that is included is roughly about 10 to 12 liters of water. Okay. So when you say tea or coffee, it means how much of the water is required for growing the tea or coffee plantation, harvesting, processing, and so on, marketing, then transport. Yeah. Then when you say tea, it is not only the tea, the sugar, then the milk, and so on. So if you add all that, then that is called as virtual water. So now we need to make a decision. Like now, if I say that, okay, why not I divert water where I grow paddy? Let us say that I divert water from a wet area to a arid or a semi area. Now, what is the problem? The water requirement increases because in a arid or a semi area, the evaporation transpiration is larger and then the yield is less. So the amount of water that goes into growing a particular crop has to be decided based upon the agroclimatic conditions. So proper agroclimatic conditions are required to grow a particular crop. You cannot say that I'm going to grow, let us say, apples in Chennai. It may not be possible. You may grow, but then the cost may be very high. Okay, so that is the thing. And then you have harvesting, processing, waste generation, and so on. Then the energy that is required comes from different sources. For example, it could be the hydropower, the biomass, the solar, the wind, the fossil fuels, then nuclear and geothermal. Yeah. So water is required for cooling purposes. Yeah. So you will see the cooling towers and so on. So this blue line is going to provide water for biomass production. Yeah. Then this is for cooling. Then extraction and processing. So if you do the, let us say, coal mining, yeah, then you need water for extraction and processing. Then you need water for agriculture. Then you need water for ecosystems. Now the food will get into this surface waters and then oceans for the aquatic animals. Food is required. Then energy is required for, let us say, desalination. Then energy is required for irrigation, pumping, and so on. So you'll see here that there is a linkage between energy, food, and water. Yeah. So this is a good diagram which explains the nexus. Okay. So are there any questions? Yeah. So this again, livelihoods, water, energy, food nexus is there. I'm not going to go into the details. You can have a look at it. Yeah. Now, what is the need of the hour? Need of the hour is adaptation. Yeah. We need to adapt for climate change. Yeah. We need to adapt for urbanization. Now, how do we do this adaptation? Now, people will say that adaptation, we will do it based on some models. Yeah. Now you will see that there is a drive for a lot of models. Yeah. Model-based predictions and so on. Now, the problem with these models is that right from the beginning, there is a lot of uncertainty. Okay. So the uncertainty base of this climate change knowledge is very large. Yeah? There are uncertainties in theory, there are uncertainties in data, okay, and so on. So because of which the predictions may not be accurate. So then how do we do the adaptation? Now for adaptation, normally what is done is that we look at the historical records. And then we look at what are called as outliers. So what are outliers? Outliers are events which lie beyond 3 standard deviations from the mean. Yeah. So supposing you plot, then events that are beyond 3 standard deviations, both from the left and from the right, are what are called as outliers. Now, adaptation, if you do it for the outliers, it is going to help you to tackle adaptation strategies for, let us say, the climate change or even urbanization. Now, to give one example, let us take the case of flooding in Chennai, because that is what I am more familiar with. In Chennai, we had a flood in 2015, November, 2 weeks. It was an unprecedented flood. Now, when we do the statistical study for that flood, we find that the return period for that flood worked out to 165 years. Yeah, which means that one such event may occur once in 165 years. So this is a historical data, which is an outlier. And if we do the adaptation strategy, let us say, God forbid, that another flood of that magnitude were to occur, then how do I do the adaptation? So what are the measures that are going to be taken to take care of such a flood? Now, that adaptation is based on an event which has already occurred, which is called as an outlier. Okay. So this is about flood. The other hydrological extreme which we have is the drought. And similarly, we had in 2003 and 4 a very severe drought which was affecting Chennai. So now, what happens if a similar drought were to occur? How are we going to tackle it? Because the conditions are not the same from 2003 to now. The area of Chennai has increased. Yeah. So you have the greater Chennai area. Then you have the population that has increased. More industries have come and so on. So if a similar this thing were to occur, what are the strategies that are going to be implemented to tackle? So such strategies are called as adaptation. Okay. So I have given here some examples, like you have now most of our mobiles come from China, from a place called as Shenzhen. About 30 years back, the population of Shenzhen was in thousands. Now the population of Shenzhen is in millions. So you can imagine the rapid rate at which urbanization has taken place in a city called Shenzhen, which is just north of Hong Kong. So if you cross this thing, then you will enter into Shenzhen. Okay. The second problem is that, as I told you, that climate change and urbanization is difficult to disaggregate. So how do I tell this effect is due to climate change and this effect is due to urbanization? Difficult. Okay. Then, as I told you, look at the climate variability, identify the outliers and adapt for the variability. That is, for the outliers only you have to do the adaptation. Okay. So there are two terms which are used. One is called as prediction and the other one is forecasting. Now here, the lady is gazing at a crystal ball and she is doing what? What is she doing? Is she doing prediction or forecasting? She is doing prediction. And what is forecasting? Forecasting has some theoretical basis. So that is why we say flood forecasting and so on. Okay. So we look at the historical data and things like that. But if you're doing future telling without any theoretical basis, then it becomes only prediction. So we have to be guided against doing prediction, and we need to depend upon scientific data for all our strategies. Yeah. Okay. I think with this we come to the end of our talk. Yeah. So what are the conclusions? Water, energy, food nexus approach is needed to address the sustainable development goals. The problem is complicated due to interrelationship between them. Need to be addressed at household level since livelihoods are important. Monitoring and evaluation of the indicators need to be looked at to see whether the targets are achieved. Baseline data may be difficult to obtain, and outliers can be used for adaptation strategies. Thank you. And I'm open for discussion. Any questions? Any questions? Participants? Are there any questions? Am I audible? Hello? Yeah. So here, when we discussed, I just try to give somewhat a little different approach as to why we need an integrated approach, starting with the Gaia hypothesis. Yeah. And then just expanding upon the Gaia hypothesis, how interlinkages are there. And then why do we need sustainable development? Why integrated approach is required? Yeah. So see, what happens is that, this is a continuous learning. Even for us, it is a continuous learning. when I finished my graduation or post-graduation or even my PhD, this concept of integrated water resource development was not there, or even there's other concepts like sustainable development goals and all. They were not there. But then over a period of time, as we move ahead, we need to learn this. So that is why when we say continuous learning is a lifelong learning, and your participation in this session or in this program is also a part of continuous learning or a lifelong learning. So this continuous learning basically comprises of three things. One is learning, second is unlearning, and thirdly it is relearning. So one has to, like we clean our recycle bin in our computer. We delete things which are not important, then we throw them out, then we put them more into this thing, and that is how progress goes. Yeah. Okay. So any questions if you have, you can put it in the chat box. So I have tried to squeeze in as much as possible within these 3 hours. But then this is just to give you a glimpse. So for example, people with, environmental background can go through that Daisy World program of this James Lovelock and see if they can use it for their own studies. Yeah, maybe you can give it as a small project to your students. Yeah, and things like that. And that is how we learn. So we learn along with our students. And all of you are teachers, I believe. Yeah. So the only way to learn is to learn with the students. On our own, we will not learn much because new learning will happen only with young minds. As we grow older and older, our ability to learn and appreciate new things become less. There is a question, is SDG 17 goal will achieve in the future or up to 2030? No. SDG 17 mainly talks of network. Okay. So now that network, how strong or how this thing is not this thing. But then the other 16 goals are important. And the idea is not to reach 100%. Yeah. We don't score 100 in every subject, isn't it? So what is the target that we put? 70%, 75%, 80%? If you achieve that target, that is good enough. Because these SDGs are for all the countries in the world. It is not only for India, or it is not only for Maharashtra or Karnataka. There are poor countries, there are developed countries, there are developing countries. Each one will have their own limitations and their own strengths. Based on that, they will achieve something. But then have we moved forward? That is more important. Yeah, thank you. Learning, unlearning, and relearning. Yeah, that is what. Because see, when I started teaching, I don't know if some of you are engineers. I started teaching a subject called surveying. Today, I can't do that because the technology in surveying has improved so much. Yeah, we did chain surveying and dumpy level. These days, it is all electronic distance measuring, GPS. Along with that, you have this new technology of GIS and so on. So unless you keep abreast with that, you will not be able to move forward. Yeah, I have shared the PPT with Professor Bandela. I will request him to share with all of you. This is to Dr. Pramod. Yeah, 58. Yeah, I think it is shared. Okay, fine. So you have any specific questions you can ask? Maybe I can respond, or maybe I will not be able to respond depending upon my understanding and limitation. But anyway, go ahead and shoot.
So any questions from the participants? Sheikh sir, you are there?